Okay, so we're going to do multiple machining groups for this example. Now this part um, is going to need some turning work and some milling work. Okay, and we're going to treat it for this time around as two separate machines. So as in you don't have a live turning lathe, you have to do this on the milling machine after you turn it on the lathe. We are not going to part this off first. We could do that after, but you'll get the gist of what's going on. I'm not going to bother with that operation. We're going to leave the stock out here. So you'll open this Mastercam file that's provided, and it'll come in just like this. Please note, make sure you check the levels. That should be what you got. You got some wireframe for me working with this to create the geometry, and I leave them there in separate levels. And in the planes, you'll see that I have top and hole. Those two are critical. We're going to use top for most of this, but make sure that the offset is 0. That'll help us force it to G54 later on. We could fix it if we have to, but it'll just save us a step. All right, so in toolpaths, it should import in just like this. And you'll see I renamed the machine group as turning operation 1 and renamed the toolpath group as turning. The post or the machine type we're using is a generic Haas 4-axis lathe. That's the one I prefer to use for all my turning files on the Haas equipment. And this is where we're going to start. So first thing we need to do is do a stock setup, the generic one in the toolpath window. So go to stock setup, stock properties. And if it doesn't default to geometry, it might go to no geometry. We're going to go to cylinder. And our stock OD is going to be 1.5 inches. And I'm really not worried about, the facing operations, like to use margins for this. We're just going to face it. I'm not really worried about it. So just go to 1.5, and a length of 3 inches is fine. That can change. It's up to you. But we'll leave that, and we'll hit green check. And we have our stock. And then our chuck jaws, I'm not really worried about the geometry of them. But in the parameters, I'm going to go to position it from stock, and a grip length of like 1 inch should be okay. We will hit green check here and green check out of here, and then go to the top view. I am going to shift this back. I don't like how the chuck jaws are that close, because I am going to turn past a little bit, and if we were to part it, it's just too close. All right. So if I go to stock setup again, go back into my chuck jaws, into parameters, I'm going to change the grip length to, let's say, 0.5. And you don't have to be super strict with, we can increase the stock length if we wanted to. It doesn't, you don't have to be grabbing on 1/2 inch if the stock was longer. Knowing that's not going to make a difference, it could change the stock model, or it will change the stock model for milling, but even that is not super critical to me in something simple like this, because as long as you got clearance and this clearance exists, you are in good shape. Okay. So I'm going to pause here, let you catch up with this setup, and then we're going to get into using can cycles, which some of you may or may not have done in other classes. So we'll work with these can cycles for roughing and finishing instead of the standard rough and finish. Okay, so what we need to do is rough this component, and we'll get the turning done. So we're working with a 3D model, and that may be new. So Mastercam is kind of nice with a 3D model. Instead of older versions, you used to have to use your wireframe and leave it there, which is fine too. With the 3D model, if we go into our canned rough, the chaining will appear differently. Before we get into the chaining, I just want to talk about this a little bit. This will give you the G71, G70 cycles and make your code a lot shorter than using the regular rough and finish. It's up to you either way. Code length is not usually critical anymore, but we're going to use this for a little change of pace. So I am going to go to canned roughing, and you'll see with the 3D model now it comes up 2D, and it's a lot easier to change. It gives you the outline of the model. Okay, so you can see this wireframe or model. So that may be new. So just expose that. It is pretty user friendly. Okay, and I'm just going to select here, change direction to here. Okay, and hit green check. All right. Now again, I told you I'm not going to worry about facing this workpiece. For this example, you could do that yourself. That's fine. But I'm going to try to keep this video as short as possible and just show you the core of what I'm trying to, what I'm trying to show you. So we use, an 80-degree insert here, and this is going to be a little different. So we're going to leave, let's say, 5 thou in the X and Z. Clearance is fine for this. Depth of cut, we're going to go 0.030 just to give us some code. I'm not worried about the rest of this. We could do clearances in the X and Z, but for right now, that'll be okay. This on the Haas is not going to kick out in 2-line format. It's going to be 1-line format, if my memory serves me right. We'll take a look at the code afterwards. One thing to pay attention to is the X diameter. Prior that would tell the machine where the stock exists or where the can cycle will exist. Make sure extend contour to stock is on, and you'll see that the stock size is now on the X. That is critical. You're going to get a heavy initial pass depending on how much roughing you're doing. The difference between the largest diameter of the chain geometry and the stock. So make sure that's there. And then lead out. I am going to lead out and extend it by 0.125. All right, and we'll hit green check. And you'll see our toolpath. Okay. Now it doesn't look a whole lot different than a standard roughing toolpath in Mastercam, but let's just post this operation alone right now and show you what goes on in the code. So it's going to look totally different. You'll see the code is pretty short. You're going to have your single line G71, your sub. Well, I guess you can call it the code callouts. Okay, here to here between 100 and 110. Your leave allowances, depth of cut, and your feed rate. Okay, then it all applies to here. It roughs it out using the standard OD roughing can cycle. Okay, notice it does look different than what was shown in Mastercam. Notice the 1.5 is here, which is excellent. That's your initial location that tells tells the machine how to break up this code for the steps in roughing. So this X 1.5 is very critical. But that looks good. Okay, so again, it's just a time-saving thing. So that's the roughing operation. I would save now. And if we go into backplot and run this, you'll see it looks very similar. Yep, and that's it. Okay, so that's the roughing operation, kicking out can cycles. We'll transition next into the finish operation. Okay, so for the finish operation, it's just going to finish the material left from the can cycle. So there's no chaining involved. So if we go down to the bottom and go to finish operation, you'll see we can just use the same tool. That's fine for what we're doing. You could change speeds and feeds if you like. We're going to add a retract of like 30 thousandths. That's good there. Again, this is the chain geometry. It's going to be lathe, canned, rough. Okay, there's no real need for the approach or retract points right now. Computer is fine. Mastercam takes care of our tool nose radius compensation for us, and we'll hit green check. Okay, just hit yes and regen the operation after that, and it does work. Let's take a look. For whatever reason, this version will give you a dirty operation. I have not seen that. 2021 tends to do that, at least recently. So those are your settings, green check, and it's fine. We can watch it in backplot. I'm just hitting the S button to go through it. Okay. And it goes around. Okay. So we're good there. Now, let's take a look at the code overall. When we post this, it's very important that you select both operations. Otherwise, you're going to get like a local subroutine for the information here, or non-local. I forget which way it goes, but it's kind of irrelevant. You want these both on. So we can go to G1 and post both of the can cycles. And you'll see that we have our G71 here. All right, there's 1.5 we talked about earlier. There's all of our code between N100 and N110. And then it goes back 70 thou away facing, goes to X 1.56. Okay. Then it goes into G70 and runs the finish operation. Okay, there would be speeds and feeds here if we had changed them. We did not, so they're going to remain the same. And it will run between N100 and N110. Okay, so we have roughed and finished this workpiece using lathe can cycles. All right, if we turn both of them on, that's what they look like. And now what we need to do is do a new toolpath group, or a new machine group, and work from there. Okay, so before we get into milling, I just want to do a new stock model. I just did a new toolpath group, stock results. We will go to stock model, and we will use a cylindrical stock, initial stock shape from the stock setup information that we created initially. I will call this turning results. And I will create it as red and in glass, so it's transparent. If I go to the view and show material, source operations are going to be the turning ops, and then after that we should be able to hit green check, and we have a stock model. So we're good there, and we can reference this later. Okay. One thing I want to show you here, I was just talking about, if you go to view and go to material, you'll see that now the stock model is transparent and the actual 3D model sticks out. That's just a handy thing that a lot of people do. So we'll leave that there. And now what we need to do is, do a total new operation. So I'm going to minimize all of this. This is just the turning operations we could access. We are going to, and while I'm in there, I am going to turn the stock view off. That way I'm starting from scratch. I will also turn the turning off, so that's out of the way. So they're both there. Make sure that these are off, the stock model's off, and make sure that your turning operations are off. So it's all kind of out of the way. Now what we need to do is go into machine, mill, and it's going to be generic Haas 4-axis mill, and you'll see that they are totally separate. So if we get rid of this one, we could rename this machine group as milling operations. There's our information. Now the first toolpath, I am going to use a stock model for this initial one, so stock. You don't have to, but the issue here is to access this one again is kind of like more clicking around. So what I do is just sort of make a copy of it. So I'm going to go to stock model, and there's no information for source operations. I am going to go to stock model turning results, and this will be copy for mill, something like that. Okay, and we'll just hit green check now, and we're good there. Okay, so now we have our stock, and it's easy to access when we're in milling operations. Okay, so now what we need to do is I am going to turn the stock model off, and you'll see already instead of having everything open, it is easier to work with. I'm going to go up to milling operations, right click, groups, new toolpath group, and this will be slots. All right. And then what we'll do, I'll transition here or pause, and we will mill these around. All right, so let's do a simple contour operation to cut these slots around. I am going to just chain one, machine one, then transform toolpath. Now one thing you got to watch out for is make sure it's not going to let you really chain in here easily because this is the y-axis. We need to look on this one here, okay, because that's this plane is perpendicular to the Z. So if we go to contour, and we could use our 3D chaining tools, that's fine. If you chain the bottom, okay, you could do that. You can get into wireframe and chain that way. But what we want to do is we want to have an open chain. So I am going to rechain all, and I like the edge option and select the edges, but see, it gives me 2 endpoints now. You can now go to the previous branch point right here and mess with the branch points, and now it gives us a nice open chain. So once that's done, we'll hit green check and green check. So this will be a contour path. The tool, if I go in here, I'm just going to do a 3/16 cutter. It could be tool 1, that's fine. Speeds and feeds, whatever you want to do. No holder information on it's critical for this operation. Cut parameters, we're going to use wear. We're just going to no rough and finish, just try to keep it simple. No depth of cuts, lead in, lead out is fine. Linking parameters. The top of stock in this case will be 4375, half of the 875. Okay, and that could be absolute from nominal, that's fine. The feed plane, everything else I'm going to leave incremental. That'll be coming from the top of stock. The depth of 0 will be going to the chained geometry. And everything else should be okay. Make sure you use clearance only to start end planer on. We'll make sure that our planes are correct, that it's on 0 like we wanted to, like I talked about earlier in the video. Coolant's up to you, it's irrelevant. For right now, we'll hit green check, and we have our operation. Okay? And you could tweak your lead-ins, that's fine. But right now, we'll leave that. All right? And now what we need to do is transform this toolpath around, and we've covered that in the past. So we'll go to toolpath transform, and we're going to rotate this. So we're going to go to rotate, tool plane, sources NCI. We're going to select the contour, copy source operation, disable it, I'm going to do assign new 0 to 0 to make sure they're all G54. In rotate, the rotation plane is going to be the right-hand plane. And we're going to do 3, angle between 90 is default. That should be good. We will hit green check, and we'll see that we are in good shape. The only thing we're going to watch out for is to make sure it doesn't double hit any of these. You'll see this is ghosted, so now any changes you make to here will change all the pockets. So let's go into backplot. Let's hit play, and that mills that, mills that, mills that, and mills that. So we're in good shape. It didn't double hit any of them because this is ghosted. So that transform toolpath is correct. Okay. Last thing we need to do is take care of, I'm going to turn this one off and this off. And I'm going to do a new toolpath group. All right, it's up to you how you want to link up your tree here. If we do a new toolpath group, this will be the hole. And I'm just going to plunge in with the same cutter, just for keep it simple. So what I need to do now is, you could select the plane later, but I'm going to go into planes, and I'm going to select the hole for C&T plane, and that'll kick out an A move. So then I get into toolpaths, and I'm just going to go to drill. I'm going to select the bottom of this hole because that'll give you circle geometry. There it goes, right there. We'll hit green check. And the tool will still be a 3/16 end mill, cut parameters, drill right in, linking parameters. Top of stock on this one should be 0.3125. And I'm going to go absolute. I kind of prefer to do that. So that's just the 5/8 diameter divided by 2. And we have a clearance plane, and we're going to do 2 inches. We can go incremental and use only at the start and end, incremental, absolute, incremental. This is going to the chain geometry. No tip compensation necessary. The planes look good. It is top, hole, hole, and that'll give us our A move. So then we'll hit green check, and you'll see we have that location. Okay. So now we can watch this run. So what I'm going to do is I'll leave both these there. I am going to change my planes back, CT to top. Just leave that there. We'll go toolpath, and we can watch this in backplot. And you'll see the cutter go ahead and go in. All right. Let me double check and make sure I picked the right cutter on that. 1/8 inch drill, I did. I was too quick on that one. So let's go back into parameters. And let's pick up the 3/16 end mill. So go back up to tool, 3/16 flat end mill, green check. And regenerate the operation, and let's watch it in backplot just to make sure. What I just saw the point on the end of the cutter, so we're good there. And speeds and feeds, again, you got to modify the material you're working with. So we'll leave that there. I'm going to select this and this by holding Control and go to backplot, and we hit play, and it goes through and does all these, and goes in and does that angle. So now we can watch it and verify. Before we do that, we go to the simulator settings. Make sure the simulation is just using a generic 4-axis, not the UMC if you were using that from the previous modules. We're going to go to stock setup, and we're just going to do copy from mill. They are identical. There's no fixtures. We're not messing with that right now. Hit green check. Make sure these are selected, and we will go to verify. And we'll go to isometric. All right, make that bigger. And I'm going to slow this down and hit play, and you'll see it machine the slots. And take care of that hole. So I don't see any crashes or any issues here right now. All right. We're good there. All right, don't see any issues. Let's get out of here, and let's take a look at our G code for the milling operation. All right, so here we are. Tool 1 is good. Notice we have a A0. And go ahead, cutter comps on, and go ahead and cuts that pocket. Cancels out, goes up to 550. All right. Then it goes to Z 2.4375, which is the radius of where we're at, which is going to be the 7/8 diameter plus 2 inches. That's the start end of every operation. It rotates a 90, negative 90, goes around again. 180 goes around again. 270 goes around again. And then it goes 550 up to the clearance plane again. Now we're into our next operation, the Haas smoothing settings, A negative 315. That just should be at, we could, again, that's that whole location in A. Okay, so again, negative 45 degrees, but it's going to a negative 315 around. That's fine. You could tweak that if you like, depending on how it's picked, but it's irrelevant. It's going to be correct. Then it goes to location, and then there's our drilling operation, cancel can cycle, and go home. Okay, so we're good there. That's our operation for this. Now, if you wanted to go ahead and do the part off operation after that, it'd be again, you machine, lathe, then part it off. I'm not going to do that with you. This is enough for now. The newest things for some of you could be the can cycles, but for everybody, the new thing is doing multiple, moving from machine to machine with the same part file, and that's the main focus here. Stock results, stock and stock models sort of linking up, but again, this is a good example of two different machine operations, one in the lathe, one in the mill. All right, one thing I wanted to add to this, and you don't have to do this for the assignment, you could leave it just as we did before, is what if you go to the machine and the fourth is not in the X negative direction, it's on the right-hand side of the table, as they normally are. But that's not always true, but let's say I know here they are on the right for the most part when they come installed, or when you walk into the shop and they're installed. So what I did is, let's ignore the stock for now, but all I did was I created a new plane, and I called it the fourth, and it's the right orientation, and I just made that plane, I went to my planes here and updated it. So fourth, fourth, fourth. Okay, and then that'll ask you to regenerate this operation, and we're good there. Notice everything's X positive. Now, the hole also changes. What I did with the hole to fix that is I went to planes, and I went to the hole, and I just turned it on just so I could see exactly what it is. And I went to edit, and I just used dynamic rotation and kicked it 180 and edited it. Once you do that, you regenerate this operation, and you should be in good shape. Let's take a look at the code for both of these. So we get into G1. And we'll take a look. So we have our G54, which is fine, our locations. Everything looks good. It's going X positive, which is what we want. Everything looks good there. All the rotations look good. It starts at 0, 90, 180, 270, and then it does 315 and goes for the hole. And it is a positive location. If we backplot it, we are in good shape. Okay. Now, what to do with the stock model, and I'll transition into that and show you that next. All right, so if you're lucky, the stock model should move with your model. So right now, if we go to top view, notice we're here, and that's using the fourth, the new work offset I just showed you that I created. If we go to top, which is what we're using in the lathe offsets, if we go to top view, it's on the other side. Okay, and again, if you go to the stock model, it should stay with the model. Okay, so we go there, and then if we go to not levels, but planes, and go for our fourth axis, kicking about the Z180, and we go to the isometric reverse or even top view, you'll see the stock model goes with it. Okay, so that's what should happen. Now, if it does not, okay, for whatever reason, one workaround is that you can create geometry by using a PMESH file, and that has been covered before. So if you go into the toolpath stock model and convert to PMESH, make sure that'll create a solid model. Like what I would do is I would do a new level, let's say, and this would be PMESH. And make sure this is active. And if you do convert to PMESH, now you have stock geometry there. We'll turn that off, and you'll see on the levels we have geometry. And you could take that geometry and move it just like the model. You can do whatever you want with it, but we don't really need that. There's a workaround just in case it gets a little screwed up on you. So there's our model, and notice on the top view with this work offset, it goes with it. So when we do our milling operations and we go to verify, if we go to isometric reverse and hit play, it looks good. Okay, so we're good there. All right. And then if we go back to turning, okay, go to our turning operations. What I will do just for reference is turn the top on everything, go to top view. and our turning operations should be fine. Okay. And again, in turning operations, you're going to turn the stock model. It's going to be stock setup. Okay, we go to green check and go to verify, and you'll see we start with our cylinder again. All right. There's just a couple workarounds. It's the PMESH again that was brought up before. Just another tool you have. I went over just moving the creating new work offset and going through and changing the options again. That is in all of your individual contours. You can update if you go right click here, and it's going to be let's see here. Let's go to edit selected parameters, edit common parameters. Okay, and you should be able to get in here, and you could change. If you work with these two, you can go to planes, and you can update the planes for everything if you wanted to. Just another option, but there's so few here, you can update them separately. But it depends on where your fourth axis is, what way it is. Okay, so that's just a little extra. Just make sure we cover that just in case you want to run this in the shop. Because again, you're going to come in, and it's not going to the fourth axis is not going to be on that side. Even the cables probably won't run that way. But some machines are like that, so it depends on where you're at. We can get into our planes and go to the fourth and go to top view, and there we're at. And I'm going to go to the isometric reverse, and in our tool paths and milling operations, we'll make sure our stock model is for copy for mill. They are identical. And if we go to backplot, we look pretty good there. And if we go in here, we're going that way. I'll just go into backplot quick so we can see this. We should be comping to the left. All right, we'll double check our code quick. And we are. So hopefully that'll help you out just in case you run into an issue there. Again, if the stock model becomes an issue for whatever reason and you're trying to do this, you could always go to the PMESH file, and you can do it at any time. Just know that when you make a change or an update, it's not going to update automatically like a stock model will. It is just representation. The PMESH is here. So again, if I turn all that off, milling operations, let's say that one, and if we go into levels, and you'll see the PMESH file. It's just a 3D rendering of the stock model that it essentially turns a stock model into geometry. Okay. So hopefully that was helpful. If you have any questions, let me know. Again, the stuff we just did, moving it to the X positive direction where the chuck would be over here, you don't have to do that. I'm not really worried about it. But the main focus of this is doing turning operations, stock models, to milling operations. Okay, then selecting this one to post this code, and then posting the other one to do the milling code, which we've done a couple times. So we'll take a look at our turning code. There's our turning code, and you could run that on that machine. Then you can go down to milling operations, post that code, and run it on the milling machine. All right, so hopefully that was helpful. If you have any questions, let me know, and thanks for watching.